My name is Miguel Crespo, and I would like to introduce you to the Newton's Laws video project. Newton's first laws of motion is nicknamed the law of inertia. It explains that this ball will not move until a force is acted upon it. And this force will continue moving until another force acts upon it. When I move it along this wood, it's not going to stop until it hits the carpet, in which the friction increases. So Newton's second law of motion explained that force is equal to mass times acceleration, or acceleration is equal to force divided by mass. So I have two balls here, one that weighs more and one that weighs less. So I'm going to go over to the camera, and I'm going to roll these two. I'm going to roll this one first and this one second. And you're going to see that this one catches up to this one if I am able to do both of them with the same force. So it caught up and it went more faster. I'm going to do it one more time. So as you can see, because this one weighs less and the force is the same, their acceleration is different. Okay, Newton's third law of motion explains that with every force there's always an equal and opposite force. I'll explain with this. If I move this forward, there's always a motion or a force pushing back against it. The mass of this, it might not be much, is pushing against it. And the friction of the wood is also pushing against it. So what happens is it eventually stops, but you wouldn't be able to see it in the camera. However, for this, it has more mass and more gravitational pull. It also has more traction because it is a soccer ball, and it has an equal and opposite force, just like this. So if I go here, it's going to stop because the friction and its mass is pushing against my force. If I have this here stopped and nothing happening, if it's not moving, what would happen is the gravity is pushing it down, but the ball is pushing it up. If it were not to be pushing it up, this would be pushed to the ground, non-existent. There would be no mass. There would be no shape, no form. This would be splat like a pancake. And same thing with this. There is a force pushing down. There's a force pushing up. This is pushing up. If I were to sit on it, like if I were to sit on this, I'm not going to do that. If I were to put my hand and press it down, then it would not crumble because it's pushing back. The air pressure in here is pushing back, allowing it to not pop, deflate, and turn into a pancake or not exist. So that's how the Newton's third laws of motion work.